Increasing world trade calls for intelligent transport solutions that are custom-tailored to the optimum means of transport. The solution is intermodal transport. Deutsche Bahn is the leading international transport and logistics service provider for European combined transport. Intermodal transport is the term used to describe a logistics chain that includes different modes of transport. The main haul of intermodal transport routes is by rail and water. The road link at the two ends of the chain is kept as short as possible. Goods are transshipped in standardized transport units such as containers, swap bodies or semi-trailers. For rail transport, special rail car wagons are available. Loading units are transferred at intermodal terminals, which are usually located at cargo logistics centers. In the Deutsche Bahn organization, DB Netz, the Deutsche Bahn network company, is responsible for planning, financing and construction of intermodal terminals. DB Netz has entrusted the German railroad transshipment company DUS with the operation of these terminals. Around 2.2 million loading units a year are handled at DUS terminals. The classic intermodal transport chain is subdivided into the following sections. The road operator or freight forwarder organizes the transport of goods to the terminal by road. Goods are handled at the consignment terminal by the terminal operator. A railway company transports the goods by rail to the destination terminal. At the destination terminal, the terminal operator is also responsible for transferring freight from rail to truck. Transport by truck to the receiver is again organized by a road operator. Intermodal transport exploits the relative strengths of each mode of transport. In Germany, as in Europe generally, intermodal transport is supported politically because it enables freight traffic to be taken off the road onto the more environmentally friendly railway. The BLU operational control system is the terminal management system for intermodal terminals operated by DB Netz and DUS, and meanwhile also used by other European terminal companies. Intermodal transport is only competitive if the different modes of transport in the logistics chain work together swiftly, reliably, and economically. International safety regulations require seamless documentation and monitoring of transport chains and transshipments. The BLU terminal management system supports all operational procedures at large and small terminal locations. As well as improved control and management of the operational processes, the system also reduces crane travel and truck processing times. BLU maps the terminal processes along the entire logistics chain and supplies crane drivers and terminal staff with all the order information they need. Truck drivers are informed about their exact delivery and pickup positions along crane runways. The terminal dispatcher can track the progress and location of loading units and freight cars at all times. The system supports the following operational processes: rail arrivals, road departures; road arrivals, rail departures; storage area management and gateway traffic; additional services; management information and statistics. Together, these processes form the core of the BLU system. Prior to transshipment, operative consignment data and status information is exchanged in real time with rail transport operators via a standardized electronic interface. This means that when a train or truck arrives at the terminal, all the information required, such as pre-announced train, rail car sequences, and consignment data, is available. The BLU communication server is the data collector and data agent between the rail transport companies, the combined transport operators, and the terminal locations. The rail operator can also communicate directly with the terminal server. Before loading units are transshipped, their order data have already been transferred. Upon delivery of loading units by road, they are inspected to ensure that they are suitable for rail transport and secure. The transferred consignment data is verified at the truck gate check-in counter. Before delivery of the loading units for rail departure, rail cars are prepared and loading positions allocated in line with specific rail car and train loading rules. As soon as a scheduled loading unit arrives, the system suggests the allocated rail car loading position as the destination for the crane transfer order. In the interactive BLU graphical user interface, orders can be created by drag and drop. A position can be selected for the loading unit on the rail car or in the storage area. The selection of crane destinations is supported graphically. The system automatically generates the crane job order. After the crane order is generated, it is transmitted simultaneously by wireless LAN to all the cranes operating on the crane runway. The truck driver is given a delivery document with the assigned position in the loading lane. The truck and the crane can now immediately move to their destinations. The crane data terminals are specially designed to cope with the harsh environment and nighttime operation. All crane terminal operations can be controlled via an ergonomic keyboard. Crane orders include the code, number, and size of the loading unit, as well as the source of the crane order. Information is also provided about hazardous goods, the license plate number of the truck, as well as the destination and any other information, such as order priorities. Crane orders can be carried out in any sequence required. This means that it is possible to respond flexibly to the situation in the terminal at any time. The BLU works according to the principle, no order, no crane transfer. After confirmation that the crane order has been completed, BLU automatically sends an electronic loading confirmation message to the rail operator. The loading unit is transported by rail to the destination terminal. The train and consignment data is provided by the rail operator in advance and available when the goods are transferred from rail to road at the destination terminal. The terminal staff checks the rail cars and loading units which have actually arrived against the announced train lists. All the rail cars and loading units are stored in the BLU with their exact grid position on the terminal crane runway. For work on the tracks and stores, Mobile data capture terminals are used. Staff can complete or change the railcar or loading unit data. Any damage can thus be detected and documented as soon as a train arrives. Data can be transferred to the terminal control center in real time or in batch mode. The advantage of batch mode is that data can also be captured in terminal areas without a wireless LAN. Data is then transmitted to the server as soon as the operator is back inside a radio network. After incoming trains have been checked, BLU automatically sends the electronic train arrival confirmation message to the rail operator. Crane orders are generated depending on whether loading units are designated for truck pickup, intermediate storage, or reloading. When a loading unit is picked up by a truck haulier, the terminal dispatcher retrieves the right loading unit based on parameters such as the loading unit number or ID code, identifies the loading unit status and terminal position information, and generates the crane order for unloading onto the truck. This is transmitted by wireless LAN to the corresponding crane terminal. The truck driver receives a printout with the pickup position and drives to the loading position to take over the loading unit. Following confirmation of the crane order, BLU automatically sends the pickup confirmation message to the rail or combined transport operator. The terminal is displayed in different sections and details so that I can always see what's going on. The graphical overview displays the rail sidings, the truck, loading and storage lanes. Colors provide instant information about the loading unit status. Arrival loading units are displayed in yellow. Departure loading units are green. Loading units containing dangerous goods are additionally displayed in red. More details can be scaled up with 2 zooms. Special pictograms of railcar types with loading patterns and railcar characteristics are displayed from a special database containing all wagons used for combined transport. A mouse click on a loading unit or railcar icon provides additional detailed information. A starter version, BLU Lite, is available for smaller terminals. A BLU Lite server can serve several terminal locations via a virtual private network, VPN. This version only provides terminal management and dispatch workstations. Crane drivers and staff on the rail sidings obtain their information via voice radio and from printout lists. However, the BLU Lite nonetheless provides all the functions of the BLU core system. Optional modules can be added to the BLU core system. As well as the standard external communication interface, individual interfaces can be implemented. The BLU Stat statistics package can be extended by the BLU Bill package used to bill all customer services and monitor settlement. Internal or hired truck haulage fleets can be managed and dispatched with BLU Truck. BLU International is available for multi-language operations. BLU Video automatically identifies truck license plates, controls access authorization, and documents damage to loading units. BLU Kai integrates the Trimodal Inland Port module. BLU Opti contains a module for optimizing crane orders to further enhance terminal throughput. BLU Web gives authorized users access to status information about their loading units. The Cologne-Eiffeltor terminal was designed to handle 320,000 transshipments a year. With BLU, we have increased this volume by about 20%. Truck processing time has been reduced by about 40% to less than 15 minutes on average. With BLU, a basis has been created for managing intermodal traffic faster and more efficiently and securely. The BLU software alone has enabled us to boost transshipment volumes by 1/5 without having to enlarge the infrastructure. This is essential if we are to succeed in reducing road congestion by getting more freight off the road and onto rail.